is approving the placement for intrauterine devices.
I'm Elizabeth Callahan.
I'm Carla Albertson.
I'm Olivia Martin.
And I'm Kathleen Peter. So to set the kind of scope for our project, we're going to start by talking about intrauterine devices in general. So IUDs are generally a small piece of T-shaped plastic that is inserted into the uterus as a form of birth control. There are two main types, hormonal and copper IUDs. They work in slightly different mechanisms. So the hormonal releases hormones into the body that prevent ovulation and therefore stop pregnancy. The copper actually releases copper ions that act as a spermicide and can sometimes prevent ovulation, therefore preventing pregnancy. With these devices, there are multiple clinical issues. So a lot of women experience severe pain upon insertion, but additionally, there is a high rate of migration of the IUD. So you can see that it's all the way up there. And this can lead to perforation of the uterine wall, and it can cause excessive bleeding, excessive pain, and a lot of really bad issues with women's lives.
To make this a little bit more real for you, we've included excerpts from a couple of testimonials, and while each of them refer to a different woman's experiences, we'll see common themes among them that tie into the clinical need that Kat discussed, including excessive bleeding, pain, and also fear. With these aspects in mind, we developed our engineering need for this project, which is a method to fix an IUD in place without irritating the uterine tissue. When we developed this, we had a couple of considerations that we need to make to ensure that this will actually work, which is that the device should still allow for fluid movement in the uterus, as some women still menstruate with an IUD in place, and this also shouldn't impede device removal, otherwise then it's counterintuitive, and why should we even bother?
As part of this, our client is reproductive age women, so roughly women 13 to upwards of 50 women when menopause begins. So that's the main client that need this engineering needs to be solved.
Our approach to finding a solution to this issue is to not change the structure of the IUD itself, but rather to enhance the actual properties of the IUD. This is a very basic drawing, but the areas that are in green would be the arms of the IUD, which actually come folded out when they're inserted into the uterus via a catheter. And our solution would be to coat the arms of this IUD with a shape memory hydrogel. We have some examples here that we could potentially use: alginate with chloronic F127 and polyacrylic acid with sterile side chains. The ideal would be alginate with chloronic 127 because its transition temperature is between 32 and 34 degrees Celsius, and the body temperature is 37 degrees Celsius. So it would be able to swell and actually maintain its shape. However, extensive testing would need to be done to ensure that these hydrogels would swell on the arms and essentially sit right at the bottom of the fallopian tube instead of the top of the uterus, just to fix the arms in place a little bit better. This hydrogel would also be porous to allow for fluid to still move throughout the uterus, as again, some women do menstruate while they have an IUD inserted, and we wouldn't want any retrograde menstruation to be occurring. And this would also be degradable. So over a period of time, potentially 3 to 5 years, again, extensive testing would need to be done to ensure the degradation rate of these hydrogels. But it could be degraded over a period of time, and then you could have the IUD removed after that without that impeding any sort of scratching on the uterine wall when the device is removed.
So with this new design, we do have several costs on both the customer side and on the design manufacturing side. First, it would slightly decrease the lifespan of the IUD, and so the decreased lifespan would mostly be accountable for the fact that we have shape memory hydrogels that are biodegradable, so that would totally depend on the degradability of the hydrogel itself. And this would also cause the IUD to be slightly more expensive, but not that much because of the small amount of shape memory hydrogel that is actually used for each individual IUD. Plus, a lot of insurance companies end up covering IUDs anyway, so hopefully that wouldn't be too much of a cost for the potential customers. And on the design manufacturing side, we would have to do that extensive testing that Liz had mentioned to make sure that the arms would unfold and the hydrogels would maintain their shape inside the uterus itself, so as to not block the fluid flow in case women are still menstruating with this IUD. We would also need to communicate with insurance companies to make sure that this new design would be covered by their policies. Otherwise, prices could go up exponentially. So while there are all these costs, there are many benefits that outweigh the costs. First of all, there would be a decreased number of women getting IUDs removed due to the fact that there would be a more personalized fit. So therefore, there is less of a chance of uterine perforation or damage to any of the tissues, which is one of the main concerns of women who get IUDs these days. And it would also decrease the amount of pain involved with insertion and removal of the device. So overall, the advantage of our device is that it greatly increases the quality of life of the women who are using these products.
So what's our competition look like?
You guys are done.